Okay, so hello and welcome. Our last video looked at memory, also finished with a look at short-term memory. What we're going to look at in this video are two theories around short-term memory and and its role, as well as working memory and how that works. So basically our focus here is on short-term memory for this video. Our first theory that we have is Craik and Lockhart's level of processing. Okay, so it's a framework that they've figured out. So they looked at short-term memory and they were looking at the idea of how do we get information from short-term memory into long-term memory. Okay, so they accept that Atkinson and Shiffrin's model of short-term memory was fine, and they wanted to look at how does it get from short-term memory into long-term memory. And they looked at what they called processing. Okay, and that is the level or the depth at which we process information during learning. And that determines how well it's stored in long-term memory. Okay, kind of like the encoding process. So, it says memories are best encoded, organized, and stored in long-term memory according to meaning. Okay, and that's going to be really important that we remember that. So you're looking at the meaning and the levels of meaning that you can put into information as it's encoded. It says that we have shallow and deep processing. Okay, deep processing is kind of like the elaborative rehearsal that we looked at just at the end of the last video. So what did they have to say? Well, they said that basically through their experiments they found that of the different ways that we take information in, if we visually encode something, just look at it, then we retain about 12 to 15%. If we listen to something, okay, then we encode about 58 to 60%. And if we encode something with meaning attached to it, then we are able to retain about 85 to 90% of it. That's a big difference between just looking at something and giving something meaning. So you're going to need to think about that next time you are just looking over your notes, okay? Or next time you rote learn or maintenance rehearse a definition, okay? You don't get a deep understanding of it, and come exam time when there is pressure, you may have trouble retrieving it. They found, Craik and Lockhart found that the deeper that you process something through elaborative rehearsal, okay, the more likely it is to stay in long-term memory. So there was a couple of ways that they suggest you do that. They suggest that you kind of put concepts into your own words to make sure that you understand it. As a group, we always do really great textbook definitions. We're fantastic at remembering that. Unfortunately, you'll rarely be asked for a textbook definition in your exam. Also, they ask that you question the information, create your own questions about it, ask more about the information. You know, there's things you can do in class about that. Also think about how to apply the information to what you already know. Are there personal experiences? So for example, if you're thinking about short-term memory, then you can think of times when you have held a phone number in your short-term memory, or for example, us playing cards on the whiteboard. Okay, that's a way of us thinking, remembering, where was the ace? Could I hold it in short-term memory? Okay, and finally create your own examples. So it's about making the information personal to you. That's really important in Craik and Lockhart's levels of processing. Okay, the more you can make information stick in your own words and use your own examples, the more likely you are to attach meaning to that information. There are some issues. Okay, limitations are that it's hard for them to define how deep the processing of something is. They haven't done it clearly. They said that there is a hierarchy, but it's not a nice clear continuum. For example, in your textbook, if you look at page 314, it shows us the different ways that you can interpret or encode or process the Australian flag. Okay, so a really shallow processing of that flag, which means not very good, would be just to process it at a visual level. So identify that it's blue, there is some red, there is some white, there are some stars. Okay, that's one way of remembering that flag. Okay. The next level, kind of an intermediate level of processing, you might say that it's the Australian flag. So that flag that has blue and stars, white stars and that kind of stuff, that's the Australian flag. That's one way you might remember it. If you really wanted to add personal meaning to it, you might think of it as, I remember when I was watching the Olympics and one of the swimmers did an amazing swim and I was cheering him home and I was with my family, and then when he won his gold medal, he raised that flag. Okay, one of the famous things about the Australian flag is when Kathy Freeman won her gold medal and she ran around with it. That was a big deal for me, so I would always remember that flag. Okay, that would be a deep processing event because I have attached it to a personal event, something that it means to me. Okay, so then that's much better than it's a blue square or rectangle with white stars on it, it's a bit of red and that kind of stuff. I'm more likely to remember the deeper processing. And it's widely accepted that deep processing leads to more effective encoding and better memory. Okay, so lots of people agree on that. So that's Craik and Lockhart. They were looking at how do we get information from short-term memory into long-term memory, and they came up with levels of processing: deep, shallow, intermediate. Some other people that did some work around short-term memory looked at it in terms of working memory. Okay, so how do we hold the information? How do we use it once it's in our short-term memory? Okay, so the two people here were Baddeley and Hitch, and they came up with a model of working memory. It's a really interesting model, and it's going to take a little while for you to maybe get your head around it, but we'll see what we can do. So before we start, what I want you to do is I want you to picture your house. Okay, so picture your house in your head, and I want you to walk through your house and I want you to count how many doors there are. So as you're walking through, you're counting the number of doors, and hopefully you get to a number. Okay, what you were doing there is that you were using Baddeley and Hitch's model of working memory. Okay, so there are three major parts. There is the phonological loop, the visuospatial sketchpad, and the central executive. I'm going to explain each of those in terms of the exercise that you just did, remembering the amount of doors in your house. So, the first part is the visuospatial sketchpad. What does that mean? Well, basically it's like having a whiteboard or a movie screen in your head. Okay? Baddeley and Hitch propose that when you use working memory, you use some visuals and you use auditory. Okay, so when you had to picture your house in order to walk through it, you dragged memories from long-term memory to your visual spatial sketchpad, and you were able to visualize your house. Okay, so it's like they were playing a movie of you walking through your house. Okay, so they took memories from long-term memory and was able to put it up on that screen, and you were able to walk through and count the doors. Okay, information is temporarily stored in this, and it's always visual or spatial information. Visual information is anything you can see or visualize. Spatial information is where things are located. So sometimes they would argue, Baddeley and Hitch would argue, if you are making a cup of tea or a coffee, where you put the cup down on the table and go to get the pot, your brain, your visual spatial sketchpad, will play a little memory of where that cup is, so you know where to go straight back to it. You don't have to try and look all around the room for where the cup is. Okay? So, visual spatial sketchpad is visual, and it's like a little movie player in your head. The phonological loop is what you would have used when you counted each door. So as you walk through your house, looking at your visual spatial sketchpad, you would have counted, there's the front door, okay, that's one, then there's the bedroom door, that's two, second bedroom door, the lounge room door, 3, 4, 4, 5. So you would have played the number over and over in your head, the phonological loop. This is a verbal working memory, okay, and it encodes and stores auditory information. Like other types of memory, there is a limited amount of storage space for the phonological loop, so you only get a certain amount of information in that phonological loop. Okay, so if you were trying to remember these numbers on your screen, you're probably doing something like 5, 6, 2, 8, 1, 7, 3, 5, 6, 2, so on. Or you might be chunking, so you might say 5, 6, 2, 8, 1, 7, 3, whatever that is. As you hold those in your brain, you're using the phonological loop. Okay, so it's in verbal rehearsal. You can almost hear the voice in your brain. Okay. Of course, common sense would say that shorter words are easier to rehearse. So if you had to remember this list of words, it would be much easier than this list of words because the words are longer, which means you have to have more space, which means some of them would drop out, okay, because you only have a certain amount of information. So now that you've got the visuospatial sketchpad and the phonological loop, how do they work? Well, the central executive is the third part of this theory, and it's like the boss. It controls your attention, so it says pay attention to the phonological loop, pay attention to the visuospatial sketchpad. I need this information in from, I need the visual of your house into the visuospatial sketchpad. Okay, as I walk through that, I want you to count how many doors. So it coordinates all of this information. Now the problem is that Baddeley and Hitch don't really tell us how that works. It just says that's what it does. Okay, so the central executive is like the boss, and it instructs short-term memory and long-term memory to talk to each other, and it tells this visuospatial sketchpad and the phonological loop exactly what to do. It looks a bit like this. So you can see on your screen here the visuospatial sketchpad. That information is rehearsed, okay, and so that's how it will stay there, a bit of maintenance rehearsal. The central executive in the middle coordinates all of this information. Same with the phonological loop there on the right, and then information goes in and out of long-term memory as needed. What they found is that it didn't really make a lot of sense. How does the central executive talk to long-term memory? How can it hold information? How much information can it hold? So they came up with this idea of the episodic buffer. And the episodic buffer enables different components of working memory to interact with long-term memory. So they changed their theory a bit. Okay, they believed that the central executive spoke to the episodic buffer, and the episodic buffer could hold about 4 chunks of information. Okay, so it could hold a visual scene, it could hold some auditory information, it could also hold some episodic information. Okay, it could hold all of those at the same time and allow them to pass in and out of your central executive or your working memory as needed. So it looks a bit like this. Central executive at the top is in control of the visuospatial sketchpad, the episodic buffer, and the phonological loop. Okay, the episodic buffer deals with episodes. Oh, there's dinner. Deals with episodes like birthdays or places and time, and those places and time talk to each other so you can see them in the visual spatial sketchpad, or you can remember them and talk yourself through them in the phonological loop. And that leaves us on to long-term memory, but that's another video for another time, so I will see you next time.